Hello, good morning. Welcome to my channel. In this video, we're going to explain the first action on the body. Supposing this is a structural element. Structural element. This structural element has its neutral axis at this point, supposing, and here becomes the x plane. You've heard about a Cartesian plane. Here becomes the y plane, the vertical direction. And here becomes the z plane. Now, there is a force that we act at this plane. So let's call that force Py. And there's a force that we act on this plane. Let's call it Pz. And there's a force that we act on this plane. Let's call it Px. This force acting on this plane will cause a moment. And let's call the moment My. This force acting on this plane Z will cause a moment. While this force acting on this plane, the x plane, will cause also a moment. Let's call it ms. Where this one is mz. That is mz py and then my and then ms. Now the first actions on the body, we have classes of forces. We have a shear force. The shear force on this structural element are this px, this py. The shear force are this py and this pz. I'm going to explain that. First of all, I want to tell you what shear force is. Shear force is simply the forces that are acting normal to the element that are acting normal about the element axis. This is acting normal. This is acting normal. When I mean normal, I mean at the right angle triangle. It's acting at the right angle of this axis. That is to say, this force is acting normal to this axis, while this is also acting normal to this axis when you resolve it vertically. So these py and pz are the structural forces. They are the structural they're the shear forces. For instance, when you have something like this, this is pz and this is py. Maybe this is px. This force is acting normal to this element axis. This is acting normal to this structural element axis. But this is acting along or parallel to the element axis. That is this ps. So when we refer this and this as the shear forces, because they are acting normal to the element axis. Now, we also have axial or normal forces. Axial or normal forces. Axial or normal forces are forces that are acting parallel or along the element axis. This is acting This is the, I told you this is a neutral element, the neutral axis of this structural element, and this is the axial force. So this is the only axial force. Px is the only axial force. Now we have a bending moment. We have a bending moment. This bending moment is the bending actions about the plane normal to the element axis. It is the bending moment about the plane. What are the planes normal to the element axis? This is the plane. These are the planes normal to the element axis. Normal to the element axis. So the bending action of this force, what this force is capable of doing, what this force is capable of doing, the bending action is going to cause this structural element to bend. And you know we're taking it from the neutral axis of the element. This is the element and this is the neutral axis of the element. So I'm explaining with a beam. This is a beam. So, but this is a typical explanation of what I should mean the structural element, because it's a space structure. Now, the bending moments are P, M, Y, and M, Z, because they are forces. These are the bending actions about the plane normal to the elements axis. While we have twisting moments. Twisting moments are mx, and they are the twisting. This is the twisting action along the element. This is going to cause this to twist. Now, having explained all this, we should also know that all these forces are going to cause their peculiar stress pattern. Shear force is going to give room to shear stress. It's going to give room to shear stresses. Axial or normal forces is going to give room to axial stresses. When we come to that, we'll explain how to diagrammatically represent this. Bending moment is going to give room to bending stresses, bending or normal stresses. While the twisting moment is going to give room to bending or normal stresses. With this few explanation of mine, I believe you've really understand the force actions on the body. Force actions on the body.